less invasive. Including this year, how many years have you gone to Woodward? So if this is your first year, your answer is 1. If this is your second year, the answer is 2. So how many years have you been at Woodward? We'll start here and go around the room. 3, 5, 10, 5, 5, Gavin, 4, Aiden, 2, 4, Wyatt, 5, Lee, 1, okay? So there we go, okay? So these are the years that students have been at Woodward. So what I'm going to do, because I'm going to need this in just a moment. Okay, so what are a lot of what we're going to do in this unit is talk about ways of visualizing the data. So let's do what we call a dot plot to visualize this data. So these are the years, and this is our frequency. So our numbers went from what? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So let's see, there were, so at 3 we had 1, and at 5, and at 10, and 5, 5, 4, 3, 4, 2, 4, 5, 4, 1. There we go. Okay. So that is our dot plot for the number of years you've spent at Woodward. Okay. So what does this tell you when you look at? So if you think about it, where do you get more data? Do you get more data by looking at this, or do you get more information when you look at this? What do you think? What do you say, the top one? The bottom, yeah. The bottom one is a visualization, so it tells you that, well, we're sort of clumped together. Without doing the math, what do you think the average is going to be? I say it's going to be 4 something, okay? So you can tell that sort of by looking at what this is, okay? And we haven't defined it, but if I gave you the definition of something that was called an outlier, what do you think that would be? Not picking on Lily. Number 10, okay? So if you think about it, if we looked at something like that, this one appears to be the data that sort of sticks out from the rest of them. So you started in first grade, is that right, Lily? Started in first grade here or north or here? Okay, well, good. I found that when I did this a couple years ago, I had more people in these higher numbers. So I'm seeing a lot more that are in this smaller range here. Okay, and so let's continue on. Now, let's talk about some of the measures that we're going to have in this unit that deal with statistics. Okay, so let's just think about it for a moment. What is the minimum of that data set? What was the minimum? The minimum was 1. Okay, minimum value was 1. Now, just think about it. If you work for Woodward, you're in the admissions office, or you work in marketing or something like that, how would we use this information? So what would be a useful use of knowing the minimum of this data set? So, I mean, we only did one class, but suppose you had 2,000 students and you got this information. What could I do with the minimum of that data set? What kinds of things? What? Yeah, so I could market things about, okay, if you've been here 1 year, how was your onboarding? Okay, how does this school compare to what? The school you came from. What other questions could I ask for people? Why did you come here? What was the decision making? Okay. If you went from a private school before, what was the price you were paying now versus the price that you're paying then versus the price you're paying now? So what I'm going to ask for is just like different ways that the different data points mean something to us, okay? So the maximum was 10. So what kinds of things could I talk about to someone who is in the maximum? Yeah, why have you stayed so long? That sounds negative. What has kept you every year? You've been here 10 years. Why have you continued to choose Woodward year after year? Austin, Henry, come on, guys. Okay, up here. Okay, so if you've been here 10 years, so then I say, okay, what? You've had other opportunities to make other choices. Why have you not? Okay, that's a negative way of saying it, but like from a positive standpoint, year after year, when you make your choice, you've chosen Woodward. What are the reasons that you keep choosing? Those are things I could ask. Okay. Now, if you think about the average or the mean, how do I get the average of that data set? Add them all up and divide by whatever this number is, 12 or 13. Okay. Now, if I were to watch the average, suppose I took the average last year, the average this year, and the average next year. What would that mean to me? Why would I watch that average? Yeah. If the average goes up, that's a what kind of indicator? It's a good. It's a positive indicator. If that average goes down, what is that telling me? It tells me that people that have been here longer are leaving, or people are coming here for a shorter number of years. Okay, so if the average goes down, then I've got a lot of people coming in 9th and 10th grade. Why would we rather them come in 1st, 2nd, 3rd, 4th grade? It's more money. Okay, so those are the things I could get from that data point. Yeah. So, I mean, if we think about it, I mean, Woodward, is it a school or a business? It's a business. What are you? You are the what? You're the revenue. What am I? I'm a cost. So there you go. So like, yeah, you're a revenue. I'm expense. Okay, that's why there. That's why there. That's why there are 13 of you and 1 of me. Okay, that's simple. There are median of a data set. It is the exact middle. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. If I have 13 people, the median, if I line up all the numbers from smallest to largest, which number is it? Not 6.5. 13. 13. What number is in the exact middle of a data set of 13? If I line them up smallest to largest. Number 7, okay, because I would have 6 and 6 make 12. So the one that's right after it, the 7th item. Okay, so the 7th item, if you lined it from smallest to largest or largest to smaller, would be the median. So we'll get to that in just a minute. So the median, what could I use that for? If I'm Woodward, what would I do? Yeah, so I know that the median means half the people have been here less than that time, half have been here more. So there might be different questions I would ask, based on that. Okay. What is the mode of a data set? Yeah, so this is this is the middle. So you've got 1/2 of the numbers are greater, and then 1/2 of the numbers are less. The mode is the most frequently occurring number. What was it in our data set? You remember? Yeah, so we did not have a mode. We call this a bimodal data set. What do you think bimodal means? 2 modes. Okay, so 4 and 5 are both modes of this data set. Okay, now let's take a look and let's move on then. So, like I said, this is not the stuff you tested. This was just sort of a discussion about the topic, but let's go ahead and use our calculator to put this data in. So I'm going to recopy this. You can copy the data from that other page, or you can copy me here. It was 3, 5, 10, 5, 5, 4, 3, 4, 2, 4, 5, 4, 1. Okay, and then we're going to use our calculator to enter this data. So I'm going to create a new document, and this document, now we haven't used this one before in this class, but it's a list and spreadsheet. So we want to create a new list and spreadsheet. Does everyone know how to get there? Okay, so it was document, file, new document. What kind of document do I want? It is a list and spreadsheet. Okay, and we're going to put you have to give it a variable name here. So it has to be a word. So I'm just going to put WA years. You can name yours whatever you want. YEAR. S. I try to name it to where it means something. Like if I name that X, that's going to confuse me. Okay, so I named mine WA years, so I would think that that is the number of years someone's been at Woodward. So now I'm going to do this over here because it's quicker for me. But on your calculator, all you have to do now is just enter those numbers that were there. So 3, 5, 10, 5, 5, 4, 3, 4, 2, 4, 5, 4, 1. Okay. Now, I'll give you a few minutes to do that. Let me go ahead and pause. So what I want to do is come back with some statistical values on this data set. Okay, so on your calculator, what I'm going to do now, guys, very important. You needed to be able to open multiple documents. The easiest way to do that, Control Document. It's going to open a new document, but not close the one that you currently had. Okay, so what did I do there? I did Control Document. I'm going to add a calculator page. Okay. And now I want some information about that data we just put in. Menu. Where do you think I'm going next? There we go. Statistics. Stat calculations. How many variables of data did we just put in? One variable, statistics. Okay. So let me do that again. So it was menu, statistics, stat calculations, one variable, statistics. How many lists did we just put in the calculator? One. Okay. Now what you have to do is you have to tell it what was the name of that list. There we go. WA years. Okay. And there we go. Okay. So this is information about this data set. So did everyone find that? I'll do it one more time. Menu, statistics, stat calculations, one variable, statistics. I have one list. The name of that list is WA years. Okay. And there I go. So it's going to tell me several things about this data set. So anytime you see X with this, the horizontal bar, X bar, this means the average or the mean, okay? So just get used to that symbol means the average or the mean. The mean is 4.2. Didn't you guys guess that a few minutes ago? You guessed the average to be what, 4 point something. There you are. It's 4.23. Does anybody know what this sigma, the capital Greek sigma means in math? What? What? The sum. The sum of all values is what? So this class has been to Woodford for how many years? 55 years, okay? You guys look good for that, okay? What do you think this sigma x squared is? The sum of the squares. So you've been to, the sum of the squares of all the years you've been to Woodward is 287, okay? Now, yes. Okay, well then there's a mistake somewhere. Go back to your spreadsheet. Okay, so it's a column. WA years, you only have 3 numbers. It's a column that goes straight down. Part. No, guys. Of this data set, we just found it. What was it? 4.0777. Okay. Now, can we just round that to 4.2? Why would you do that? It's not costing you any money. Write down what the calculator gives you to be as accurate as possible. Sum of all years, we said that was what, 55. Sum of squares, what was that? I can't hear. It was what? Sum of squares, 287, right? So 287. What was the minimum value in the data set? Oh, sorry. Median of the data set is what? 4. So the median of the data set was 4. What was the minimum value? Maximum value? 10. Number of elements in the data set, 13. So you're pulling all of that off of that. And then standard deviation, where it says SX, that is the standard deviation, 2.12736. And we'll talk about that. 2.12736. Okay. Now, standard deviation is a complicated formula. We're not going to make you do by hand. What you need to understand for this class and for anything that shows up on the SAT, PSAT, standard deviation is a measure of how dispersed the data set is. The median and the mean are a measure of what kind of tendency of the data set. Not dispersion, but what? Use your words, guys. What is it? The median or the mean tell me what about a data set? Not max, but average, the middle, the center. Those are measures of central tendency, okay? The standard deviation is not a measure of central tendency, but a measure of how dispersed the data is, okay? So we'll talk a little bit about that in just a few moments. But these are things that just came straight off of the calculator. So this SX, that's standard deviation. Number of data elements, the minimum, the median, the max. And we'll talk about these Q numbers in just a moment, okay? So let's move on and let's talk about standard deviation. So you don't need to know this formula. It's a little bit complicated. This is something you would get in statistics. But the standard deviation is the measure of how far something is dispersed. So it means if something is dispersed, it means it's far away from the what of the data set. The center, the average, okay? So what you see here is I told you that X bar meant what? X bar is the what? The average, okay, the average or the mean. So this is figuring out for each element in the data set, how far is it from the average? It's squaring those, it's adding them together, it's doing a complicated calculation, okay? But what's after here is just you need to conceptually understand that standard deviation talks about how far something is dispersed from the middle of the data set. Yeah. So if I look at this curve or this distribution, last class didn't know this. You've seen this before. What is this called? Bell curve, okay? Another word is the normal curve or a normal distribution. You'll get more details about that if you were to take a stat class. But what this means is if this is the middle or the center of my data set, then standard deviation tells me how far something is distributed in the data set. So 1 standard deviation away, 2 standard deviations away, 3 standard deviations away. So we're not going to get into the nitty-gritty details of this calculation, but in stat you could get much more involved than what this is. But we just want to give a general idea of what something means when it's distributed, okay? So what I want to do now is just take an example of a couple of data sets, okay? So I'm going to use this data set, cars on Main Street, and I'm going to put that in my calculator. I'm going to plot it, and then I'm going to come out with statistics on this particular data set. So let me get my book real quick so I can copy from there. So what page is that? 108. So let me get to 108. So what we're going to do, we're going to just practice doing the same thing we did, entering the data. So I'm going to enter the speeds of the cars on Main Street. So I'll go back to my calculator. And so what I can do here, I can go back to this same spreadsheet and now put Main Street, or I could do Control Doc and create a new one. Doesn't matter, okay? So I'm just going to do it all on one here. So I'm going to say I've got cars that are on Main Street. So I'm just going to type in Main Street here. So Main ST, that should be fine. And I'm going to enter all of those car speeds that you see on Main Street. And I'm going to go ahead and just pause the video. So how did I create the dot plot of the number of years you've been at Woodward? What did I do? I drew it by hand, okay? There's an easier way of doing that, okay? So Control, Document. I can make the calculator do the dot plot. So that's going to be data and statistics, okay? So again, what did I do? I did a Control, Document, data and statistics. What you don't want to do is document, new document, because this is going to say, do you want to save? So it's going to close your other document. You don't want to close that spreadsheet. Why? It has all your data. So you want to just be in the habit of doing Control Document. It just adds a new tab every time. So What variable am I interested in right now? Main Street. Okay, so it will do the dot plot for me. Okay. Yep. So did you do, where's your data? That's because they're not lined up. It should be one column. Yeah. So, hey guys, very important. This has come up a couple times. This is the way the data has to be lined up. Okay. This is your variable. Everything in this column is that variable. If you have data over here, it's not related to that variable. Okay. So it has to all be lined up on a column. Okay. So this is a dot plot of the car speeds on Main Street. Now, take a look at this and just, what do you think about cars on Main Street? Main Street, College Park here. What do you think the speed limit is? 35. You guys have taken tests on this, right? Are going to. So it's probably 35 miles per hour. What does it look like that's happening on Main Street? I mean, the cars are going faster than the speed limit. Okay. What do you think the average speed is there? Maybe 42, 43, something like that. Okay. So the average is probably somewhere in here. Okay. So I'll figure that out in just a moment. How would I figure out that? What would I do to find the average? Yeah, I would just come over here. Let's create a new document. It's a calculator. What do I do there? Menu, statistics, stat calculations, one variable, one list. Which list am I going to use now? Main Street. Okay. What's the average? What's the average speed? 43.66. Okay. Okay. Come on, guys. You're going to have to pay attention. Okay. This is probably the fourth time we've done this particular one. Okay. Control document, calculator. Okay. Menu, statistics, stat calculations, one variable statistics. Okay. I've got one list. The name of that list is Main Street. Okay. That gives me all of these data elements. Okay. So if I look at it, the average is 43.66. So if I go back to my chart, 43.66, so my average is about right here, something like that. So that is, so if I said the average speed on Main Street is 43.66, does that accurately give you a great reflection of what's going on? No, if I just tell you the average speed is 43.66, well, you know that means cars are going faster than speed limit, but you don't know. Certainly you see here, and you see it's a much bigger problem than 43.66, okay? I've got cars that are going, 48 and 50 and above. So it looks like I've got as many cars going above that as I do below. What would I do to figure out the middle of the data set where half the numbers are bigger and half are smaller? What is that? What element is that? The what? Not the mode, the median, okay? So let's figure out what are all these things. So according to our data, the average was what, 43.66. What was the minimum of this data set? It's 31, maximum 51. And then what did our thing say the median was? The median was 46. The median is 46. And where's the standard deviation? No. Standard deviation is right here, SX. Standard deviation is right here, 5.77763. So 5.77763. Okay. So the other thing that we'll have to do a little bit of in this section is, so what are the statistics telling me? Overall, when you look at this, what is this chart telling you about the speeds on Main Street? Yeah, so people are, in general, people going over the speed limit. Now, your stat teacher would sort of have a fit because this is a very generic statement. In statistics, you will say, I am 95% confident that people are at least going 5% over the speed. You'll get very detailed about it. We're not doing that here. I can just get a general feeling like it feels like people are really going above the speed limit because the speed limit is here. So that's in general terms what I'm finding. So is the mean a good representation of what's happening in this data set? No, it doesn't really reflect a lot. It's one number, okay? Unfortunately, when it comes to your grade in this class, what do I use for your grade in this class? The what? The mean, okay? So let's just do it, say, for example, suppose this half of the room makes a 60 on the next test, and this half of the room makes 100 on the next test. What is the mean? It's 80. If everybody over here makes a 60, everybody over here makes 100, the average is 80. So I could send a letter home to all of your parents, hey, good job. The average grade in this class was a B. Is that an accurate reflection of what I just described? This half of the room made a D. This half of the room made an A+. This side of the room feels okay. The fact that the average was a B doesn't help anybody on this side of the room. So the average is not always a good indicator of what's happening in the data set because it's one measure, okay? So in this case, the mean is probably not the best way to describe this data set. What is the median? So the median is what, 46? So what does that tell me about the speed? So what can I infer from the median? Is there a question, Austin? What can I infer from the median? What do I know? Once I know the median is 46, what do I automatically know? I know two things from there. I know half the cars are doing what?
Going up, half the cars are going.
Yeah, half are going slower, half are going faster. So if the speed limit is 46 and the speed limit is 35 and the median is 46, what do I know at this point? A lot of the cars are going over the speed limit because half of them are over 46, half of them are under 46. So really, I mean, that tells me more than the average speed being 46. Okay, so I know a little bit about quantities when it gets to that. So guys, some of this stuff I'm just trying to bring back to life. But beyond just putting in your calculator and spitting out numbers, what are some things you can infer from the data set? So let's do another example. I've got another street, which is Cambridge Avenue, which runs right between this and the middle school. Let's put this data in and let's do these same calculations. Dot plot of Cambridge, and I want to get the statistics, okay? So how do I get the dot plot? Control, document. What kind of document is it? Data and statistics, okay? What am I interested in right now? Cambridge. So there I go. This is what's happening on Cambridge. Now, this one looks quite different. So in this one, what do you think the average is going to be? I mean, the average is going to be maybe 26, 27, something like that. If I say that the average speed on Cambridge is 27, is that a good reflection of what we see the data telling us? No, what is this data telling us? Yeah, there are two extremes to the data. So the average doesn't really do a good job of indicating. The average of the other data set was better able to describe it. This one, the average has nothing to do with what's going on here. It looks like instead of one data set, this looks like what? This looks like two different data sets. So in statistics, you would probably study this as two different data sets. Now, this is where your job as a data analyst is not to punch in numbers. Tell me, what do you think is happening on Cambridge? There we go. Leah's on top of it. What happens Cambridge is right over there. What happens at Cambridge in the morning? Yeah. We got little kids that we're trying not to run over, okay? So their parents are driving in, their parents are driving slower, they're trying to behave. So if you're a 10th or 11th grader, you're not on Cambridge, you're driving fast on this side of campus, okay? So it looks like, okay, in the morning, this is where kids are getting dropped off. What happens at 6 o'clock on Cambridge? The kids are gone, and all those barricades and things, what do you think happens to those? They're gone. That's what happens on weekends. So it's probably more likely that I'm getting these speeds. I hope that in the morning between 7 and 8 o'clock, these are not the speeds you're seeing on Cambridge, okay? So this is where, this is where your job, if you were doing this kind of thing, you would have to say, what is the data telling me? Well, I can look at it and see it's telling me the average is 26, but I'd have to say, why is Cambridge different than Main Street? And that's where you guys picked up. You know something about Cambridge This doesn't happen on Main Street, okay? So that's just an example of you gleaning intelligence from the data if this were your job to do that. Now, how do I get the statistics? Control document what? Calculator, or I could go to an existing calculator. Menu, statistics. Stat calculations, one variable, one list. What is the list I'm interested in right now? Is Cambridge, okay? So that tells me information about the Cambridge data. And so Cambridge is this one. Yeah, so if I go back to here, what am I figuring out about Cambridge? So what is the average on Cambridge? The average is what, 25,933? Our minimum speed is what, 12? What is our maximum speed? 40. What is the median of that data set? 32. And the standard deviation is standard deviation 11.85. Now, what was the standard deviation on Main Street? 5 point something. This standard deviation is 11. What does standard deviation tell us? How what? Dispersed. Which of these is more dispersed? Cambridge, okay? It's dispersed because the standard deviation is larger, but you can look at this. Okay, where's the average here? The average is what, 32? Okay, so here's the average right here. Okay, is the data is there more data away from the average here versus more data away from the average here? So it looks like if this is my average, is the data in general closer to the average there, or is it closer to the average here? Where is it further away? Yeah, the bottom one is more spread out. That's why I see a standard deviation. So what you might see on the SAT or PSAT is not find the standard deviation. They might give you this plot and this other plot and say which of these has a higher standard deviation, okay? So without knowing the average, you should be able to look and say, okay, you guys were able to do this. The average is somewhere right in here. And then here you could probably say, yeah, the average is somewhere right in here. And you can tell this data is more spread out from the average. So that's really all you need to know for these tests. If a standard deviation test question comes up, is it tells us how spread out things are. Okay, so we talked about this. What do we infer on Main Street versus Cambridge Avenue because of what you knew was going on Cambridge Avenue. So what we want to do now, you guys got an email from me, so if you got a laptop and you want to follow along, it's not required, but you can sort of do this activity. The next kind of visual we want to talk about is something called a box plot. So it's sometimes called a box and whisker plot. Why do you think it's called box and whisker? It looks like a box that has whiskers, okay? So the whole purpose of this kind of plot is to divide the data set into fourths, okay? So this is 1/4 of my data set from here to here. This is 1/4 of my data set. This is 1/4. And what do you think this is over here? 1/4, okay? So you divide the data set up into four. So it's just like a dot plot, but it's just a different way of visualizing this particular data set. So let's look at your smiling faces. So you can do this back home. So guys, let's see how many people we have here. 1, 2, 3, 4. Is that whoever this is that your hand? 5, 6, 7. I think there's 8, 9, 10, 11. There's 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24. Okay. So 24 people in this. Okay. So if I want to divide this up into fourths, how does 24 divide into 4? 24 divided by 4 is 6. So if I find the first 6 people, 1, 2, 3, 4, 5, 6, okay, that's going to be a marker. What to do? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Somewhere right in here is the next group. Okay. 1, 2, 3, 4, 5, 6 is the next group here. 1, 2, 3, 4, 5, 6. Okay. Okay, so you should be able to, if you're following this back at home on your laptop, You can annotate with that. But anyway, it's not necessary to do it. So this is a box and whisker. But now, what does this tell me when I look at this? Okay. So first of all, this whisker is much longer than that. What does that tell me? The data, is the data more spread out here, or where's the data more clumped together? Yeah, over here I have several people that fall in this height. Okay, we're not going to cast dispersions on anyone, so they're tightly squeezed together. Here you see the data is much more spread out. Okay, so anyway, so this is another useful way of looking at the data. So if I told you that the average height was, let's just say the average height is 5'7", that doesn't tell you a lot. But when I can look at this, I can see, it looks like the data is really gathered. There are a lot of people in this particular area here. Okay, so we have a name for this point. What is that point of the data set? The median. Okay, so if I had a box and whisker plot, this point right here would be the median. Okay, what would this point right here be? The what of my data set? This is the minimum. This is the what? Maximum. Okay, over there. And then we have other names for this. We're going to call this, I say it's the Q1. Q means quartile. That's Q2, and this is Q3 right here. So it's just a divider, okay? So if I were to ask you, where are the 25% tallest people in the class? Where are they? They're right here, okay? And then if I were to ask you, where are the 25% most height challenged people in the class? Most height challenged would be, did I say 25%? What is it? Did I say 25 or 50? The 25% most height challenge is here. Where are the 50% shortest people? That's from here to here. So that's what a box plot will do for you. Okay? Pardon me? Well, that seems to be real picky, doesn't you, Henry? Okay.
You know your actual height,
Henry, you're at the tall end of the spectrum here, and you're complaining over there. To do to this chart. Yeah. So if we had Walker Kessler in our class, we're going to have something over here like this, and I'll try to draw a basketball, okay. So, okay. So what do you think that does to this chart? Yeah, so here's my choice. My choice is I can say this whisker now goes all the way over here. That's what makes this chart look funky, okay? So what I could say is instead of them making the whisker go all the way there, I could say this data point is a what? An outlier, okay? So your box chart, when you create a box chart, you may have situations like Walker where you've got an outlier, okay? And so you don't have to know the calculation behind that. Your calculator will do it. So let's jump back in real quick and do a few more examples of finding a box plot, because I need you to be able to find a box plot on your own before we get out of here. So we talked about what the box plot will do. It will divide your data set up into, it will tell you outliers. It will give you, this is your minimum value. This is Q1. There's your median. That's Q3. And there's your max, okay? And then I can ask you questions about that. So let's be able to do that. So let's go back. You've already got this data, the Cambridge Avenue, in your computer, in your calculator. So let's create a box plot for Cambridge Avenue. So what I need to do there is control document, data and statistics, okay? So what do you think I'm going to do here? Cambridge Avenue, okay? Now, this is a dot plot. What do you think I want it to be? Box plot. Where do you think I would go? Plot type. Where do you think I would go next? You guys are on top of this. Box plot. Okay, I thought you were on top of it, but we'll go back. So, I'll do that again. You got it? Control doc, a new data and statistics. I'm interested in the Cambridge data. That's a dot plot. But what I really want is a box plot. And voila, there is my box plot. Now what you can do is, if you mouse over, this will tell you what is the minimum of the data set. 12. What is the Q1? 14. What is the median of the data set? 32. Q3 is 37, and the maximum is 40, okay? What if I ask you for, what are the 25% slowest speeds on Cambridge Avenue? Where do they go from? Yeah, so the slowest 20%, 25% would go from 12 to 14, okay? The 50% fastest would be from where? From 32 to 40, okay? So this just divides your data set into 25%, 25%, 25%, 25%. So if I go back to here, so my box plot, I'm not going to draw it here. You can do it on your calculator, but the 5-number summary, when you see that 5-number summary, it's asking for the minimum, Q1, the median, Q3, and the max. So the minimum we said was what? 12. Q1 was 14. What was the median? 32. What was Q3? 37. And what was the other one? 40. 40. Okay, that's it. Okay. What I might do on the test, I might ask you to draw that box plot. So you would have to do, something like this, and I would make you do 12, 14, 32, 37, and 40. And then I could ask you questions about the data set. So this just walks through what we did to create that box plot. And like I said, you can ask. So what percentage of the cars are between 12 and 14 miles? Yeah, 25%. Between 32 and 37, 25%. These answers are going to either be 25 or 50 or 100. Between 37 and 40, that's also, what, 25%? What about between 32 and 40? Yeah, that's 50% because that's the median to the max, okay? And again, those numbers, what were they? 12, 14, what was that, 32? 37 and 40, okay. So there are two ways of getting this information, guys. So we saw this information earlier. We just saw it coming from a box plot. The other way to get this information, calculator page. And what did we do earlier? Menu, statistics, stat calculations, one variable, one list. That list was Cambridge. If I look at this, all that data we saw a minute ago, we didn't know what it was. The minimum was 12. Q1 is 14. The median is 32. Q3 is 37. Max is 40. So it's a visual representation on the box plot, but that's where this information comes from. And that's also what we call the 5-number summary. So I think this is close to the end. Let me look and see. I know we're covering quite a bit of stuff today, guys. Oh, yeah. This is all the thing I want to do. I want to go back to the Cambridge data. And God forbid this happens in real life, but I want to put a car that's going 75 miles per hour on the Cambridge data set. So let's go find the Cambridge data set, which is right here, okay? So I've got a car that now we just decided is going 75 miles an hour on Cambridge. Now I can go back and let's just find, where is that box plot for Cambridge? Right there, okay? Oh no, that's Main Street. Where did I have Cambridge? I could always create a new one. Well, I'll just create a new one. Let me just go ahead and create it anew. So if I look at Cambridge, so that's the dot plot. You see my 75 over there. But what was I looking? I was looking at it as a what? Box plot. And what do you see there? Now, so what do you think this means for Cambridge? This data point is what? It's a what? It's an outlier. So what's the maximum of this data set? 75. So the maximum is 75, but that's an outlier. So if I ask you questions now, when I ask you about the top 25%, I want to look, say, from here, okay? The top 50% comes from the median, okay? But what I look at is, from this standpoint, it would look really crazy. This thing sticks to, like the Walker-Kessler effect. It makes the whisker go out too far here. So I'm going to call that an outlier for the data set, okay? So you don't need to know why it's, I mean, the calculation behind it being an outlier, other than the computer figured it out for you and made that an outlier. And let's see where we are at this point. There it is. Okay, and I think that's it. Okay,